Hello there, and welcome to another DevNation. We are going to have a great show for you guys today. We actually are going to deep dive into a technology related to business rules and business processes, and of course, how that relates to Quarkus. You guys have seen a lot from us over the last few weeks or last few months about Quarkus, our supersonic subatomic Java. And I encourage you actually to go back and watch and review the recordings that we have out there on YouTube just to get more context for that. But you're now going to see exactly how we've taken a new project into this new world, and I'm very excited today to have Mario with us. Mario, of course, is our Drools project lead. He's been a big time committer in all sorts of open source over this last several years, and he is our guru and expert for all things business rules and business processes. So at this point, let me turn it over to Mario. Mario.
So hi guys, and thank you, Bart. Yes, I joined the Drools project 8 years ago. Now I'm the project lead since 1 year, and we wanted to move Drools to the cloud, to make it cloud ready, and to join the Quarkus revolution. And this is why we started this new project, which is basically a rebrand. Well, not only a rebranding, more a repackaging and a big refactoring of our business automation suite. So basically, what is Kogito? Again, Kogito is a new platform that, of course, is based on rules and JPPM. Of course, we are not rewriting a full-fledged rule engine or workflow engine from scratch, but we did lots of work to adapt them, to make them cloud ready, and to integrate them with Quarkus. And so what we want to offer is a comprehensive business automation suite that can run on OpenShift, that is cloud ready, that offers automatic integration based also with automatically generated REST API to fully integrate a web application with a decision server or a workflow engine. As I said, I'm the leader of Drools, so I will speak about mainly of the rule engine part today, and there will be another presentation in September from Maciej Widerski, which is my great friend and the project lead of JBPM. I will give you more details about it toward the end of the presentation. So this is what Kogito is supposed to be, but a super small demo worth more than 1,000 words. So let me give a very quick demo. Let me share my screen. Okay, so what I wanted to show is that I have a very simple rule, and I want to expose this rule as a web service using all the Quarkus goodies. So and moreover, I want to also use the native capabilities of Quarkus. So I created a native image of this web app, which is very simple. I'm not creating the native image now, because as you can see, it takes quite a lot to compile it. It takes almost 2 minutes on my machine, but once you have it, it's super fast. It's up in really, you see, 3 milliseconds. So it's extremely fast. And this is what we really were looking for, and I will clarify this in a minute. So what I have here is that I have a super simple demo rule just have a result and 2 person. I'm looking for a person who is named Mark, and I'm looking for a person with a different name and that is older than Mark. So I defined this rule, and then I created a very simple web service, which is basically again an hello world, which calls my service. In this service, I'm injecting the Drew session, which is configured here by name. So yeah, here I have a configuration file that says this specific how this specific session is configured, and I'm injecting this session into my service in a very simple way. Well, basically with plain CDI, and yeah. Yes, I'm inserting 3 person, Mark, and a person who is younger and a person who is older, and I'm expecting giving the rule that the engine will find this second person, and of course, if I try to invoke the service, you see it's super fast. It prints the expected result, which is the output of the rule. Okay, of course this is a very simple, let me say, very stupid rule, but I just wanted to show how it works, and this is where I really started, when I started trying to integrate our stuff with Quarkus, and when we started this Kogito initiative. So I will go further with this demo toward the end of this talk, but I wanted to show you the target, the destination of this effort. But we are all developers, and we all know that often the journey is at least as much important, and probably twice more interesting than the destination. So the idea of this talk is also to demonstrate how we get there. The minimal agenda of this, as I said, this is also compilable in with a native image, and to do this, we had first to understand what GraalVM is, which features and limitation it has, and how, and this impacted a lot on rules. So we had to change the rules to fit in this picture, and then we integrated the Kogito with Quarkus by developing an extension and also implementing the auto reload, which is the last thing that I will show at the end. So again, the idea of the talk is explain how we get there. Why? Because I told you that I joined the Druze project 8 years ago, and in reality, Druze it's even older. It's like 13 years old. So it's a quite old project, and of course, when it has been designed and developed, we didn't have the cloud in mind. So it was totally, well, it is a well-established, it is a very robust and bulletproof rule engine, but it is a traditional Java framework. We didn't have the cloud in mind when we developed it, and we had to change something. First of all, we had to change something to fit it with Graal, because again, we wanted the native compilation provided by Graal. So what GraalVM is? GraalVM is a polyglot virtual machine that works with bytecode and then with all languages supported by the Java virtual machine, but also with other languages like, I don't know, Ruby or Python. And it is able to do all the optimization that the normal just-in-time compiler does, but even better, it is also able to do this cross-language. So, for instance, if you have a Java method which is calling a Python function, and the Python function is small enough, then the Python function can be inlined in the Java method invocation. So it provides the same goodies of the just-in-time compiler, but also cross-language. And the other very important thing, which is the most important thing for us, is that it allows you to create a native image, a native binary image of a Java program. Okay, so this is what we wanted to do. We wanted to be able to create a native image of a Druze-based project. The important thing of Graal is that it does lots of static analysis up front, and as I said, it works in a similar way than the just-in-time compiler, but it does a lot of optimization, not just in time, meaning while the program is running, but ahead of time, meaning during the compilation phase. Okay, and this allows to have a smaller program and of course a super fast startup, because you are not launching the Java virtual machine anymore, but you are launching a native image. The problem of this, at least for us, is that Graal comes with some limitation that are understandable. The biggest part of this limitation is that I didn't mention this, is that Graal is based on what is called the closed word assumption. So it assumes that it knows everything about the classes it will be used, there will be no specific Java virtual machine tricks like dynamic class loader and reflection, because otherwise Graal VM is not able to solve this Java trickery, this class loading at compile time. Okay, so in Druze we did a lot of dynamic class loading, because you saw we have you saw a typical rule, we have a few constraints, and then we have a consequence which is basically is translated into a Java method, and then we put all this stuff in classes, and we do a lot of dynamic class loading, and this is totally unsupported in Graal. Graal has some other limitation that in reality didn't affect us, meaning that it cannot run some native virtual machine interfaces, and it doesn't allow to have a security manager. It does support to finalize that anyway is deprecated and stuff like this. This really didn't affect us. What did affect us a lot is that you cannot have reflection. Okay, or better, you can have reflection if you follow the closed word assumption again, meaning that you have to tell to Graal, look, I want to use reflection on this specific class, and then you can configure that class in a JSON file and give the JSON file to the Graal compiler. But in reality, we didn't want to do this, and also we didn't want to. We had to get rid of all use of reflection in rules, which again was a lot because all the constraints were evaluated, of course, by using reflections. Okay, so what we did is that we introduced what we called the executable model. Okay, so what is that? It's a model, a pure Java model of a rule base. So here I have the same rule that I showed you in my demo, and now we have something that translates this rule into a Java model using this DSL. Don't worry, you don't have to write this DSL by hand. This is automatically generated for you. So our parser parses the rule and generate this Java method. And you can see now that all the constraint and being translated into lambda expression, and the consequence, the right part of the rule became a lambda expression as well. Okay, and moreover, in the executable model, there are stuff that we had to avoid reflection and to make everything explicit. So there are stuff that Druze did for you, like setting some indexing and using a feature that is called property reactivity. All this stuff was inferred from the DRL, from the rule language, but it's written explicitly, generated for you inside the executable model. Okay, so the executable model allowed us to have a DSL, a Java DSL representation of our rules, and also it has a set of good feature, of nice feature, but again, the most important for this talk is the last one in this bullet list, is the fact that it allow us to not use anymore any reflection or any dynamic class loading, and then allowed us to have our rules natively compilable on GraalVM. So we don't need a dynamic class load anymore. Now our internal class loader just throws an exception in the define class method because we don't need it anymore. But you have to change it because otherwise Graal will bump into that dynamic class load definition during the code analysis and will refuse to create the native image. So we have to just have a specific class loader for these cases that doesn't do any dynamic reflection. And then I showed you that I quickly showed you during my initial demo that we have an XML file when we define our the properties of our rule bases and sessions that we have in our project. You cannot parse that file anymore. You need a lot of reflection as well. So what we did, again, we learned the lesson from the executable model, and now we also generate a Java class, a Java file that carries the same information that you type in the XML configuration file. And same thing, you cannot use reflection, as you said. So we had a lot of wiring of our services based on property file. What we had to do is hard coding the name of these services in a Java file. Why? Because this is interesting. You can use class for name with a constant, as you see in the right side of this example. Why? Because this is not breaking the closed word assumption. If you replace that constant with a variable, Graal doesn't know anymore what the class is, and it doesn't work anymore. Okay, so this is the way we had to change our internal wiring of services to make this work. And why we did this? Because if you run a very simple example like the one that I showed you before, by launching a Java virtual machine, as you see from this screenshot, it took me 73 milliseconds and took more than 100 megs of RAM. Okay, if you do exactly the same by launching the native image, you have a sub-millisecond execution, and it takes only 16 megs of RAM. Okay, so it's almost 100 times faster and almost 10 times less memory occupation. And this is what you want. This is what we wanted, because we wanted to have Drupal to function as a function, as a service, as a decision service, as a function that can take decision for you. That when you invoke it, start it, run the rules, take some decision, and returns it. Okay, so this is why we did this lots of work to allow native compilation. And then once we had this native compilation ready, in reality, we started to look at the Graal before knowing the existence of the Quarkus project. Okay, and then we have been lucky on time, because they announced this Quarkus initiative, and it was really what we wanted, because of course having a simple Java application is not enough. You want to leverage all other technologies that you are used to use. So as I showed you, I'm using exposing my services with a REST API, and I'm using CDI, and I may want to integrate my rule engine with a camel root, or monitor it with Prometheus and Grafana, or feed it with Kafka Stream. So I really want to integrate all the cool Java technologies, the largely used Java technologies with this stuff, and Quarkus offered us the possibility to do this. Okay, so with Quarkus you can have this native executable, which is the thing that I ran before. If you do a native image based, of course, on Graal VM, or you can run it with a plain Java virtual machine. And this is what you do mostly when you are in development mode. So then we needed to sorry, we needed to integrate our stuff with Quarkus. So we created a Kogito extension for Quarkus, and what we did in this extension, you have a build step that has to create that is just a method annotated with that build step annotation, which is just a method that in our case it was very simple, because we already had that code generation bit. So we just wired it. We are invoking the code, the generation of what we call the executable model, and then we also started code generating some automatic REST endpoint. And what we do is just registering these Java classes created on the fly inside Quarkus. Okay. and this is basically all what we did to integrate Kogito with Quarkus. The next bit was that we need to also enable the hot reload. So Quarkus is very cool if you started playing with it, meaning that you can launch it in development mode, and then you can change some Java classes while it is running, and you don't have to bring it down and restart it. You have the hot reload of these Java classes. And of course, we wanted exactly the same thing for rules and decision for our rules files and decision tables and processes. So we also created added the possibility to have hot reload for our DRL file. Okay. Yeah, of course, Quarkus wasn't ready for our stuff. It was taught only for hot reloaded of Java classes, but we hacked a bit with Quarkus. We sent some pull requests that has been discussed a bit and then merged, and this allowed us to have our hot reload feature, and it was also a very nice experience because all the Quarkus guys, the guys working on the core platform, are very open to discuss improvement and new use cases to which they simply didn't think about. And then yes, I showed you very first example of a website of a very simple REST API that you can implement with Kogito. Let me show you another example, which is the example of the slides. So let me share again my screen. So I will bring down the server. This time I will restart it in development mode. Okay, so now for our case, our extension is recreating all those classes that I mentioned before. So if you go in the target folder, you can see the generated classes for our project. Okay, so this is, for instance, one of the generated executable mode rule of the executable model. Okay, so now I'm invoking another service which simply tells me if I'm old enough or not to drink. So I am exposing this REST API, and if I pass to it a Mario person which is old enough, it will tell me that of course I can drink. Okay, but I launched this in dev mode. So this means that I can change the rule. This time I coded my rule with a decision table. So I guess I will need to share it. 1 second. Okay, I'm sorry, but I'm not able to share the Excel file containing the decision table. Okay, so let me try. Sorry about this. Let me try with the other rule. So, for instance, this one. So again, this is saying this now. I can, I guess, do this. And as you can see, the auth reload is reevaluating the rule with the new rule without retriggering it, and under the hood, Quarkus did a node replacement of my rule files. Okay, so this is basically all. What's next is that we are designing a new modularization of rule that is based on a concept called rule unit. We are better integrating rules with JBPM because we want this unit of work, this unit of rules to be orchestrated by JBPM. We are as I said, developing a new integration with Camel, for instance, with Camel Root, Kafka Stream, and stuff like this. And the other thing is that it's something on which I started just now, is that we want the generation of some automatic REST endpoint. So if, for instance, you write a query in your DRL, Kogito will generate for you a REST endpoint that you can call, and when you call it, it will populate as a address session and invoke that query, and you'll be returned with the result of that query automatically without basically writing any line of code. So this is all on my side. As I said, Maciej Swiderski, who is the JBPM lead, will do a follow-up of this talk on September the 5th. So he will show you the JBPM side of this, and hopefully he will show you also part of this new implementation that I'm mentioning today. And that's all for me, and I'm open for question now. Thanks. Any question? Bar?
Maybe now I'm live. Okay, we actually are out of time, Mario, so we actually have to finish this call rather rapidly. But I did try to answer the questions in real time. I provided links in the chat for people to get more information. There was one question related to a REPL, so like an interactive shell. Is there an interactive shell somewhere in there for maybe editing business rules or something like that? And then the other one is does the change to the business rule, the compilation of that business rule, is that a blocking call?
Sorry, I didn't get the question.
Do you have an interactive shell?
Yes, it's the console, the console of IntelliJ. Yes.
Okay.
You mean an interactive shell to change the rules? So
right.
No, you just change them inside your IDE as a plain source file. Yes, and then if you have decision table, they are just plain Excel files, so you just change with Excel.
Okay, and edit, save, refresh. So for those folks who are new to Quarkus, remember, edit, save, refresh. Edit, save, refresh. That's the model we live in now. All right, well, thank you so much for that, Mario. We're out of time, and thank you all for hanging on the call today. But if you have further questions, certainly find myself or Mario out on Twitter. Thank you so much.
Thanks a lot. Bye. Thank you.